Hello students, welcome back to the tutorial on CAD from the NX. So today we will see the so-called the placed features that directly obtain the features in a three-dimensional sketch. Exactly, we will see today the how to create the holes, standard holes on the three-dimensional sketch, and we will see how to make the shell that's useful for the making the bottles, some thicknesses, for example some bottles, some surfaces and so on. And we will see the how to make the edge blend that hold the parameters of the how to make the edge blend. Then we will see how to make the draft, no the not draft, the chamfer. We have seen the how to make the edge blend and chamfer in the two-dimensional, but in this case we will see in a three-dimensional object. Then we will see all the options of the how to make the draft. Then we will see here how to obtain the inner thread and outer thread for the object. So let's start. For the beginning, let's select the sketch, select the plane and press OK. Draw the rectangle from center, for example, any dimension, and extrude it, for example. OK, and select the hole function. In the hole we will have the several type of the hole. For example, the general hole, drill size hole, screw clearance hole, thread hole, and hole series. We will see all of them step by step. Let's start with the general hole. In the general hole we have the several forms of the holes as a simple hole, counterbored hole, countersunk hole, and tapered hole. So in the simple hole, firstly, in order to obtain the hole, we have to specify the point of the hole. We have to define the face where we want to make the hole. For example, this face. Press this face, and you see there is the dot is created, and we can specify the point of this point by the rapid dimension. For example, we can define the position of this point from this and this side. For example, the 30 millimeter from this side, and for example 40 millimeters from this side. We defined the position of the hole and press the finish. So from this point the hole is created. It is the simple hole. That simple hole, let's see from this side. You see it is the simple hole, and we can define it is the diameter, for example 15, and we can define it's the depth, for example it's the 60 millimeters, or we can define the value of the depth, for example until the selected, until the next, or through body. For example, if the through body, it will go the through body, and until the selected, if you selected this face, it will be go through the body. That's the value, and it will become 15. And the tip angle is the 180 is the standard angle for the tools. That's for the drilling tools. It's the 180. We can change it as we have the value, for example 130, and so on. In the Boolean logic, that's always in the holes, it is the subtract, because we are making the hole. So this is the type of the simple hole. If we press OK, you see the hole is created. Let's double click on the simple hole. Let's view from this side. And if we change the form of the hole from the simple to countersunk, we will obtain this kind of hole. The value of the counterbore diameter is this diameter, and it should be always bigger from the diameter of the drill than from this side. For example, let's change the values. Let's change it to the 25, for example, and the counterbore depth is this depth. Let's change it for the 15, and the counter diameter, let's remain the 15, and also the depth. For example, let's make it 40, and so on. Also the tip angle of this, and also we can make the depth according to the limit values as a previous one. Also, it is in the boolean is a subtract always. Press OK. You see, counterbored hole is created. Another form of the hole is countersunk. That is, the countersunk diameter is this bigger diameter, and also we have two angles. It's a countersunk angle, this angle, and the tip angle, this angle. Also, the diameter is this drilling diameter, and the depth is 40. Also the same that we can define the value according to the limit values in this kind of hole. If you would like to make the let's see the last tab of the hole is the tapered hole, this kind of hole. So in the diameter, for example, if it's 20, the bigger diameter, and the tip angle, this angle, for example, is 30, and the depth, for example, you can make it 60, and so on. So let's obtain the simple. And if you'd like to make the hole at the angle, you can make the along the vector, for example, to change the hole direction, not the normal to face, but along the vector. In this case, you can make it by the 2 points and define the 2 points. For example, this point and this point. You will obtain the hole, not at this point. Let's make it at this point. You will obtain the hole in the angle, and if you make the value that through the body, you can obtain the hole in this direction. From starting from this point and this point, also you can make the in this point or in this point, and as you want, as the sketch is required. This is the how to obtain the hole forms. Also, we have the type of the holes. For example, the drill holes. Let's close this one and delete this one. Open the hole. From the type of the hole, let's make it a drill size hole. This drill size hole is used for the milling operations, for the CNC operations. If you needed some drill holes, you have to choose the drill holes directly from this part. So in this case, you have also predefined the position of the hole from, for example, this face, and this hole position is created, and press finish. And here from the form and dimension, there is the standards for the drill sizes. It's the standard sizes for the drilling operations, and you can define your required drill size, for example 10, and the depths you can define as you previously, that's the limit, or just give the value and the tip angle. Press OK. So drill hole is created. This is the standard holes for the drilling operation during the milling operation. So the same, the threaded holes and screw holes that can be obtained. Screw holes and threaded holes can be obtained. There is the standard sizes for the threaded holes exists in the market for the drilling operations for the threads in the existing standard values for the threads. So in order to see the series holes, that whole series, let's draw one more object. For example, let's firstly define the datum plane, new datum plane at a distance. For example, there is 2 datum planes, and press OK. Let's draw one rectangle for this datum plane. And extrude it. That's enough. And let's draw one rectangle for this also. Extrude it also. That's enough. And open the hole and choose the type of the whole series and specify point and press OK. You see, in the whole series there's directly the system defines the holes for the consequent objects. So it's the start object, this is the middle object, and this is the end object. So the hole is seriously created step by step for the all series objects. It's the easy, so it's the simple hole. And from the start you can define the type of the holes and the standard values for the holes, and you can define the depths, the tip angle. Also you can define the values and the limit values. This is the how to obtain the whole series object, that the whole series holes. So this is the all about the how to create the holes. And let's continue the edge blend. For example, the edge blend, let's we can delete all of this. And we can delete this datum place and remain just this rectangle. For example, in the edge blend, if you select the edge blend function, you will see two type of the circular and conic. Firstly, we will see the circular edge blend. If you select any edge, for example in the edge blend, it will be made rounded. You see, its the diameter is 20 millimeters, and you can change the values by hand. I just drag and dropping this arrows. It is symmetrically changed. So, or you can change the value by putting the numbers, for example the 30 millimeters and so on. So also in the here you see the variable radius points. If you open the variable radius points and select the specify points from here, if you make the end points, let's select the end points of this one, and this one, two endpoint is selected, and you can change the values of this end values and make the variable radius point. So, or you can put it in the number, for example 20 millimeters here, and from here you can change the values 20 millimeters. So it is the same. Also from here you can select the point on the edge and select this edge, and you can make it in the middle, for example, and change the middle value radius, for example, to 10. And you see here you will obtain the various shape of the edge blend. You see, let's make it to change the color in order to be see the exact effect of the edge blend. Assign the feature color, specify color. Okay, you see, from this side, for example, we see here the constant value of the edge blend. Constant value of the edge blend in this side, and here we see various value of the edge blend. For example, in the various value of the edge blend, we can here define the many points, more than 3 points according our project. So for example, let's delete this part and make the edge blend again on the 3 corners. For example, let's close this one, and here we have corner the corner setback function. In the corner setback function, if we have 3 edge blends in one corner, for example, the select endpoint, selected this point, and we can open this list. We have 3 edge blend, 1, 2, and 3, and we can define the values of this corner blanks by hands or just with the number. For example, here we have this value is 10, for example, the 15, and this value, for example, the 15, and this value 15, and so on. We can define the different, or in this case we defined the same numbers of the corner blank, and you can define the different values for this corner blank. So it is the how to obtain the corner in the case of the edge blend. Okay, it's clear about the corner setback, and also we have the function, that's the option of the stop short of the corner. Let's open the stop short of the corner. So specify the point, select the endpoint. If you select, for example, this endpoint and drag and drop, you see you can define the exact position of the your your blend. So if you press OK, you see here you can define by hand the position of the edge blend. So also we have the trimming option that use the selected object by the plane. For example, also we can define the limit position of the edge blend. For example, if you select this edge, you can define the limit position for the edge blend. Also, you can change the direction from this side or this side. This is the about all the functions of the edge blend. I think there is no any question about the edge blend. Let's continue with the chamfer function. We can delete this all. So let's continue with the chamfer. In the chamfer, if you open the chamfer, there is the option to select edge. If you select the edge, you see you will obtain the chamfer as in the two-dimensional sketch, but in this case it is in a three-dimensional sketch. This is the cross section is a symmetric. It means it is the same from 70 and 70 millimeter from the both sides. You can change the value by putting the numbers here, for example 20 and so on, or by the hand you can change the values. In the case of the symmetric it is, but in the case of the asymmetric you will see the two values from the two sides. If you, for example, drag and drop this arrow, only this value is changing, that this one is constant on. You can change this value in different way of this one, so you can put the numbers here, for example 30 and 20 and so on. In the offset value, offset and angle, you will define the distance. This is the distance, and this is the angle of the chamfer. So it is simple about the chamfer. I think that's the clear about the chamfer value. So next is about let's continue with the draft. In the draft we will see different values. That's the, for example, from plane or surface, that from the edge, the tangent to the face, to painting, to parting edge. So let's start with the from plane and edge. So in the from the plane edge, you have to first specify the vector, or you can define this face, for example, and you have to define the stationary parting face. So that's the fixing stationary that face. So this face, sorry, specify the vector, this face, stationary face, and select the face where you want to make the draft. So for example this face, you see it is the 10 degree of the with the draft. Of the draft, you can change the values, or you can write here the values, for example 30 millimeters and so on, and add new set, and you can make the draft for this angle, add new set, and you can draft angle for this angle and so on. You can make the different values, for example in this side, for example 20, and this draft angle 30, this draft angle 30, and this draft angle is 20 millimeters. You see here 30, 30 and 20 and so on. And here also you will see the draft method. There is now we use the draft angle. It's the stationary face draft angle. So there is also option the parting face and stationary and parting face draft method. So we see there's the stationary face draft angle. That's this face was stationary. Sorry, this face was stationary. So open the draft from plane, and let's see what is the parting face. In order to see what is the parting face, let's draw one sketch on this face. Let's draw the arc, and let's make extrude it in the symmetric value, and that this plane that should be bigger than this rectangle. Press OK. So we obtained this plane and make the draft. that's the from plane or surface. That's the method parting face. That vector lets to define this face, and select the stationary parting face. We have to define this plane, and select the face which we would like to make the draft. This face. You see, only this part is drafted until this face. So, for example, the add new set and this angle. Press OK. Let's hide this. You see, this is very important function to make the draft in the complex shapes. Also, for example, let's delete this one, and for example, sketch one cylinder, any with any diameter. So extrude it, for example, in this position, and select the sketch and this plane. Press OK. Also, for example, we can draw arc in this position and extrude it in the symmetric value. That's the should be a little bit bigger. Press OK. Draft with the method of the parting face from the plane and surface. Select the parting face, this face, and select the face where we would like to make the draft. This face. You see, only this part is drafted. Let's see it. This is the method of the draft using the parting face. This one, it is very useful, and I think it's clear. Let's delete this. Sketch. Draw the rectangle. Extrude it. Press OK. Okay, next is the method of the drafting is the stationary and the parting face. It's the making the draft using the two previous methods. So in order to do this, let's make also the additional sketch that as previous on this plane. For example, let's in this case draw line, extrude it for in the symmetric value. Press OK. Okay, draft, stationary and parting face. Specify the vector. Select the stationary face. In this case, it is this rectangle. Select the parting face. No, sorry. This vector. In this case, this method. Stationary face, this face, and the parting, and this. Select the face where we would like to make the draft. This face, for example, and this face. Press OK. Hide this one, and you obtain such kind of draft in this method. Delete this one. Okay, open the draft, and we will see other types of making the draft. For example, from the edge, it is very easy. You have to first define the vector, and you have to define the edge in order to make the draft. This, for example, you see. Also in the edge, if you open here this one, and you have variable draft points, So if you define the points, for example, this point and this point or more point, and you can by hand define the values here, the draft angles, different variable draft angles, for example this one, and for example like this, and specify the point, for example the point on the edge, for example this point. We can define the different points, and you can make the different draft angles like this by hands or by putting the numbers. So it's making the draft angle using the from edge and from the points. Let's delete. And we have also the tangent to face draft angle, to make the draft angle. In this case, let's delete this one. In this case, for example, in the case of the tangent faces, if you have the tangent faces like the edge blend, for example like this, let's make it bigger, uh, you you cannot do the draft angle like from the plane. Like this you cannot do like this, it will be mistake. So in the case of the like the tangent face in the like the edge blend, you have to use the tangent face to make the edge blend. So you have to specify the vector this and select the face of the tangent, so this face, in order to make the draft. So you can make the draft in the case of the such kind of cases. This is the last part, to parting edge. So it's almost the same of about the parting face. So specify the vector, select the plane. Now in this case, for example, firstly we have to split the bodies. In order to split the body, for example, open the more and split the body, select the body and select the face. That in this case, let's do this face that's we already defined, this face, and okay, let's hide this. So the body is split in the two parts. So draft to parting edge, select the vector, this vector, select the plane, it's a stationary plane, this face, select the edge, so this edge. So you will make the draft until this splitted object. List. Like this. This is the all functions, that's the possibilities of how to make the draft. So let's delete this one, and next is to make the shell. Let's delete this one, this also. Let's see the shell function. That shell is needed in order to make the scene walls for the solid functions. It's very useful to obtain the bottles and such kind of objects. So we have the two type of the shells, that's remove face then shell, and shell all the faces. So let's see firstly remove faces and shell. So in this case you have to select, for example, this face, so you will make the shell of the object on this file at 5 millimeters. So let's make it a 10 millimeter. So you can make the shell, or for example select also this face. You can make the shell, such kind of solid objects convert to the shell objects. So also if you see here the alternative thickness, so if you select for example this face, you can differently give the value for this value. For example, let's make it a 20. So only this side will become the 20 millimeters and others remains as a 10 millimeters. So add new set, and we can make also 10 millimeter of this side. Press OK. This is the how to make the shell, and this is very useful for to making the, as I mentioned, for the making the bottles. So delete this shell and open the shell, and we will see the shell all faces, and select the body. Selected, press OK. So it will become the inner shell for the whole the bodies, and we can see this by the making the view section, and you see inner shell of 10 millimeters from the all the sides. This is about the shell function. Let's see the last topic of the today about the thread, how to make the inner and outer threads. In order to make the thread, let's select a plane and sketch any cylinder and extrude it, and open the more thread. We have two type of the thread, the symbolic thread and the detailer thread. Detailer is very useful though. Detailer thread. So selected this, and this will define the exact that values for this, and taking the minor diameter, length. Okay, let's define the value for this. For example, 400 exact value. Finish it, and also for the extrude, let's make it 700, and open the thread. Select this one. So you see it is the major diameter is the which we draw for the circle 400, and it will define the system is smart, so it defines the minor diameter. It's 394. Also we can change this value as we want. For example, the 390 and so on. That length, that extruded length, and that's the pitch and angle. So press OK. So we obtained our thread. If you would like, for example, to change the values, you can double click on the thread and change the values to obtain another threads for the for this. Okay, This is the how to make the outer threads. Let's see the how to obtain the inner thread. For example, in order to make the inner threads, you have to select you have to draw the hole. For example, in this here, and extrude it in the opposite directions. That's the limits. And this, let's make it 100, and subtract, press OK. So hole is created, and open the thread, detail it, select this face, and this is defined by the system. And for example, press OK. For example, let's make it more bigger. Okay, let's draw another object. So delete this one, delete, sketch. Okay, select this face, hole, for example any hole, extrude it, subtract, press OK. Open the thread, detailed thread, select this one, select the start point, this one, OK, and press OK. So you see the inner thread is created, and if you see here, there is inner thread. So dear students, this is all about of today lesson. That we have seen how to create the holes, shell, the draft, edge blend, the chamfer, and the thread, inner and outer thread. This is the topic of the placed features, that existing placed features for the three-dimensional object. See you on the next lessons.